Chapter 4 deals with data acquisition. Here are our objectives. Okay. We're going to talk about the three storage formats for digital evidence: the raw format, proprietary formats, and the AFF format, the advanced forensics format. Raw format makes it possible to write bitstream data to files. The advantages of using raw format include fast data transfers, the capability to ignore minor data read errors from the source drive, and most computer forensics tools can read raw format. Disadvantages include it requires much storage space as the original disk or data, and tools may not collect marginally bad sectors. Proprietary formats have advantages and disadvantages. Advantages include the option to compress or not to compress image files, the ability to split an image into smaller segmented files, and the capability to integrate metadata into an image file. Disadvantages of using proprietary formats include the inability to share an image between different tools and file size limitations for each segmented volume. Now, the AFF Advanced Forensics format, developed by Dr. Simon L. Garfunkel of Basic Technology Corporation. Okay. Design goals of this format include they provide compressed or uncompressed image files, no size restriction for disk-to-image files, provides space in the image file or segmented files for metadata, simple design with extensibility, open source for multiple computing platforms and operating systems, and offers internal consistency checks for self-authentication. The file extension includes .afd extension for segmented image files and AFM for AFF metadata, and AFF is open source. Okay, to determine the best acquisition method, there are two types of data acquisition: static and live. Okay. The four different methods for acquiring data include bitstream disk-to-image file copy, bit disk-to-disk copy, logical disk-to-disk or disk-to-disk data, and sparse data copy. Some of the main considerations when acquiring evidence data include the size of the source disk, including the compression methods. When working with large drives, an alternative is kept using tape backup systems, and whether or not you can retain the suspect's disk. Trying to just get caught up on my slides here. Contingency planning for image acquisition. A list of considerations to take to prevent copies of the evidence from damaging or losing. duplicate your evidence copies, acquire more than one image of the evidence using different tools or techniques, be prepared to host protected areas, and be prepared to deal with encrypted drives. Acquisition tools. There are advantages and disadvantages for using acquisition tools for Windows, including make acquiring evidence from a suspect drive more convenient, especially when you use them with hot swappable devices. You must protect acquired data as well as with a well-tested write-blocking hardware device, because you don't want to change the original. And tools can't acquire data from the disk host protected area. Windows XP write permission with USB devices. The USB write protection feature in Windows XP Service Pack 2 blocks any writing to USB devices. The disadvantage is that the target drive needs to be connected to an internal PATA, IDE, SATA, or SCSI controller. Here are the steps to update the registry in Windows XP Service Pack 2. Back up the registry, modify the registry with write protection feature, create two desktop icons to automate switching between enabling and disabling writes to the USB device. Acquiring data with a Linux boot CD. Okay. Linux can access a drive that isn't mounted. Windows operating systems and newer Linux automatically mount and access a drive. Forensic Linux live CDs don't access media automatically, which eliminates the need for write blocker. A forensics Linux live CD contains additional utilities that are designed to mount, not to mount. To mount is read-only any connected storage media. Some of the well-designed Linux live CDs for computer forensics are Helix, Penguin, Sleuth, and FCCU. Linux distributions can create Microsoft file allocation table and NTFS partition tables. And here are some steps for preparing a target drive for acquisition in Linux using the fdisk and mkfs.ms-dos command, and acquiring data with DD in Linux. The DD dump data command can be used to read and write data from a media device and a data file. The DD command creates raw format file that most computer forensics analysis tools can read. The shortcomings of using DD include it requires more advanced skills than the average computer user might have. It does not compress the data. Now the DD command combined with the split command segments output into separate volumes. The DD command is intended as as a data management tool. It's not really designed for forensics acquisitions. The FLDD command offers additional capabilities. There we go. Additional capabilities including specifying the hexadecimal patterns or text for clearing disk space, log errors to an output file for analysis and review, use several hashing options, refer to a status display indicating the progress of acquisitions and bytes, split data in acquisitions into segmented volumes with numeric extensions, and to verify acquired data with the original disk or media data. Now capturing an image with the ProDiscover Basic program. The steps include document the chain of evidence for the drive, remove the drive from the suspect's computer, configure the suspect's drive jumpers if you need to, connect the suspect drive, create a storage folder on the target drive. Now, you can use ProDiscover raw acquisition format. Saves only the image data and the hash value. Using capturing an image with FTK Imager. It's included on the Access Data Forensics Toolkit. FTK Imager allows you to view evidence disks and disk-to-image files. It also makes disk-to-image copies of evidence drives at logical partitions and physical drive levels. You can segment the image drive. The evidence drive must have a hardware write-blocking device on the USB write protection registry feature enabled. FTK Imager can't acquire a drive's host protected area. And these are just some slides of some of the steps involved. Validating digital evidence is probably the most crucial aspect of computer forensics. Validating digital evidence requires using a hashing algorithm utility ranging from CRC32, MD5, SHA-1, or SHA-512 to SHA-512. Linux validation methods, you can use the MD5 sum and SHA-1 sum commands to validate data acquired using the DD command. The MD5 sum or SHA-1 sum utility should be run on all suspect disks and volumes or segmented volumes. Windows has no built-in hashing algorithm tools for computer forensics, but third-party tools can be used. Several commercial computer forensic programs also have built-in validation features, and each program has its own techniques. For Windows validation methods, raw format image files don't contain metadata, so separate manual validation is recommended for all raw acquisitions. RAID data acquisitions. Okay, the size is the biggest concern because many RAID systems are now pushing into many terabytes of data. I guess it helps to understand how RAID works and what it does. Okay, um, it used to RAID used to stand for Redundant Array of Inexpensive Disks. Now it means independent disks. Okay, it's a computer configuration that requires two or more disks. Originally developed as data redundancy measure for fault tolerance features. Okay, and there are different levels of RAID. RAID level 0 basically is a performance enhancement. It provides rapid access and increased storage, but lack of redundancy. I wish there were. Okay, here's RAID 0. Okay, it's just like saying, well, two men can unload a truck faster than one man, so two drive mechanisms are faster than one. RAID level 1 is a form of fault tolerance, data designed for data recovery. It is more expensive than RAID 0. In RAID level 1, okay, rather than keep jumping back and forth. RAID level 1 includes disk mirroring and disk duplexing, and basically everything that's written to one drive is written to another, and basically if one drive mechanism goes dead, the data is still on the other drive. Disk striping. Here we have RAID 2 disk striping. Basically you're treating multiple mechanisms, drive mechanisms, multiple drives, as a single logical drive, and you're writing data across the drives. Okay, RAID 3 uses data striping with dedicated parity. RAID 4, data is written in blocks. Now RAID 5 is similar to RAID 0 through 3, but places the parity recovery data on each disk. In other words, just as the data is written across all drives in the stripe set, so is the parity information. The nice thing about RAID 5 is that if a single drive fails, the data still is available because the smarts that make up RAID 5 can actually figure out from the data on the remaining drives what should have been on that bad drive, and then it's still available that way. And if you replace the bad drive with a good functioning drive and repair the RAID 5 stripe set, it will write back data to that drive that should have been there, and it figures it out from the data and the parity information on the remaining drives. The limitation on RAID 5 is only one drive can go bad at a time. Okay. RAID 6 is redundant parity on each disk. RAID 10, or mirrored striping, also known as RAID 1 plus 0, or a combination of RAID 1 and RAID 0. Alright, so you acquire RAID disk. What are the concerns? How much data storage do you need? What type of RAID is being used? Do you have the right acquisition tool? Can the tool read a forensically copied RAID image? Can the tool read split data saves of each RAID disk? Older hardware firmware RAID systems can be challenging because when you're making an image. Some of the vendors offering RAID acquisition functions include, there we go, Technologies, Pathways, ProDiscover, Guidance Software, Encase, Xways, Forensics, Runtime Software, RTools Technologies. Occasionally a RAID system is just too large for static acquisition. Retrieving only the data relevant to an investigation with the sparse logical acquisition method is the practical solution. Remote network acquisition tools. You can remotely connect to a suspect's computer via network connection and copy data from it. Remote acquisition tools vary in configurations and capabilities. Some of the drawbacks include the LAN's data transfer speed and routing table conflicts could cause problems. Gaining the permission needed to access more secure subnets. Heavy traffic could cause delays and errors. You can do remote acquisition with ProDiscover. The functions available through ProDiscover Investigator include preview a suspect drive remotely while it's in use, perform live acquisition, encrypt the connection, copy the suspect's computer's RAM contents, and use optional stealth mode. Additional functions available through ProDiscover Incident Response include capturing volatile system state information, analyzing current running processes, locate unseen files and processes, remotely view and listen to IP ports, run hash comparisons, and create a hash inventory of all files on a system running remotely. Okay, PD Server Remote Agent is the ProDiscover utility for remote access and needs to be loaded on the suspect's computer before a remote connection can be established. The installation modes include trusted CD, pre-installation, and pushing out and running remotely. PD Server has the option of running in a stealth mode. In addition, you can change the process name so it appears to be an operating system function. Remote connection security features offered by ProDiscover include password protection, encryption, secure communication protocol, write-protected trusted binaries, and digital signatures. Encase Enterprise acquisition. Features that it supports include remote data acquisition of computers' media and RAM data, integration with intrusion detection system tools, options to create an image of data from one or more systems, and preview of systems. Also, a wide variety of file system formats are supported, and RAID support for both server and software. Remote acquisition with RTools and RStudio. RTools RStudio software. It's a suite of software designed for data recovery. Its remote connection uses triple data encryption standard, 3DES encryption. It creates a raw format acquisition and supports various file systems. Okay. Remote acquisition with runtime software. There we go. The utilities that it includes Disk Explorer for file allocation table, Disk Explorer for NTFS, and HD host. Acquisition features are offered by runtime software include creating a raw format image file, segment the raw format or compressed image, and access network computers' drives. Other acquisition tools include Snapback Data Arrest, SafeBack, DIBS USA RAID, iLook Investigator Imager, Volgon International SDI32, ASR Data Smart, and Australian Department of Defense PyFlag. Snapback Data Arrest characteristics. Let's see. It's an old MS-DOS tool. Okay. DIBS USA RAID, Rapid Action Imaging Device. Another thing to remember. Rapid Action Imaging Device, RAID. Okay. It's a portable computer system designed to make disk-to-disk images. Copy disk can then be attached to a write blocker device. iHook Investigator, iX Imager, runs from a bootable floppy or CD, designed to work only with iLook Investigator and can acquire single drives and RAID drives. Vogon International. I don't think I need to read this. Now, this Australian Department of Defense PY flag program tool is intended as a network forensics analysis tool, can copy proprietary format expert witness image files, and uses these in Linux. That's a lot of information for one chapter. Take a while to sink in, but you're reading the chapter, right? Right.